Welcome to the Ruby Dungeon, a series teaching how to code Ruby scripts that can be run with the Lich program. Here are some things we learned so far. In episode 3, we learned how to make .lic files, use the echo, respond, fput, char.name commands, if, else, coding on one line with a semicolon. We went over case sensitivity and if on one line. In episode 4, we looked at the Lich scripting reference page, infomon commands, huntpro code examples, script.exists, script.vars1 downcase, strings versus integers, approximate or exact match, more info on case sensitivity, and .to_i and .to_s. In the alias refresh video, we had a quick tip about using ;E to write in-the-moment scripts, and you can attach them to an alias if you desire. Today we're covering a lot of material on the concepts of dry, variable types, proc calls, modules, vars, and settings. Seatbelts on, let's get started. Dry. No, we're not talking about humidity levels here. Dry stands for don't repeat yourself. When writing complex scripts, you might end up pasting the same block of code in several places. While this totally works, it can make your code look bulky and hard to manage. Here's the real problem. If that code is in, say, 9 different places, and you need to make a change, you're going to have to update it everywhere. This is time-consuming and can lead to mistakes, like missing a comma on line 237. The good news is that Ruby and many other programming languages help you avoid this. You can define a block of code once and use it whenever you need it. This way, if you need to update a value, you do it in one place and it updates everywhere. This makes your code cleaner, reduces errors, and makes it easier to understand. In today's video and future episodes, we will explore how to use the dry principle to simplify your coding and make your scripts more efficient. Let's talk variables. We're going to cover 5 types of Ruby variables today: local, global, instance, class, and constants. For now, we'll focus on local variables, the simplest type. Here's a practical example to illustrate the dry principle. You create a variable by giving it a name and a value, and then you can use that name to reference said value in your script. Instead of typing the number 1 every time I want to show a kobold's level in a script, it could be defined with a variable. Here you'll see kobold_level equals 1. With that code, defining kobold_level with the value of 1, I can use kobold_level instead of typing 1 in different places. This not only makes the code cleaner, but easier to update. If the kobold's level changes, you only need to update it in one place, and the value will flow to the rest of the script that makes decisions on the new data. You must define a variable before you can use it in a script. So looking at this code, we have a comment that says my script, and then we're using echo here to tell the value of that variable. So echo, open double quotes, number sign, open brace, kobold_level, close brace, close double quotes. If I try to run this script right now, it's going to give me an error because we didn't define kobold_level. So here's the updated code. Kobold_level equals 1, and then echo, the command we used before. This is going to output the number 1 because we defined kobold_level as 1. To see the value of a variable, you can use different commands. We previously covered echo and respond. I'm going to go ahead and add _respond to that list, which we'll cover more in depth next episode. We're also introducing print and puts. Print does not add a new line character, so subsequent output will continue on the same line. So here's some code using print. Print, and then we're going to use double quotes for these examples. Hello, and then on the next line, print, we're going to use double quotes with a space between the quotes, and then on the third line, we're going to do print Alenthea in double quotes. So when this runs, it's going to output hello followed by a space and then Alenthea all on the same line. Here's a similar example using puts. Puts and then the double quotes hello, and then on the second line, puts Alenthea in double quotes. This is going to output hello on one line followed by Alenthea on the second line. Here's a new concept, number arrays. Don't worry too much about this yet. We will revisit it in future episodes. When you're outputting an array with puts, you'll use puts and then open bracket 1, 2, 3, close bracket. This will print each element 1, 2, and 3 on a new line without those brackets. If you output an array with print, you're going to do print, open bracket, 1, 2, 3, close bracket, and that's going to print 1, 2, 3 on one line, including those brackets. Here's outputting variables with puts versus print. So we want to make sure we define our variables, name equals kobold in the double quotes, then level equals 1. And now when we're using puts, we do puts, and then put this in double quotes, name, colon, and then we're going to trap that variable, #, open brace, name, close brace, close double quote. And then do that for the second line for puts, level, and we're going to put the level variable there. So now our output is going to have name on one line, which is going to be kobold, and level on the second line, which is going to be 1. If we do something similar with the print command, it's going to output the name and kobold all on one line. For numeric values or decimals, don't use quotes when defining the variable. So here we have some numeric values, kobold equals 6, and then we're going to use puts to output that value. And then we have kobold equals 6.5239, so on and so forth. And then we have kobold equals negative 55.93111. So when we output this, it's just going to return those values that we entered. All of these examples are valid. When dealing with a combination of text and numbers, or just text by itself, use quotes. Single quotes and double quotes handle strings a little differently. With single quotes, you can escape special characters with a backslash. Think of it like this. I want you to print this character exactly as I have it right here. So when you have single quotes with escape characters, we're going to do kobold equals single quote IT \S, a test of seeing if I can type the, and then you use double backslash here inside of a single quote, and then of course the closing quote. And then when we output the variable, it's going to give the full sentence without the extra backslashes. The backslash apostrophe prints that apostrophe, and the backslash prints that backslash. Double quotes allow for special characters like new lines. Here, \n creates a new line. Tabs don't seem to work in the Lich program, but you would do that with \t. Local variables don't stick around when the script exits. The name of the variable and their value goes poof. So here we have kobold equals 6, and then I'm going to put some comments to the right of my variable now. And then we have stuff happens, script ends. After we run this script, the kobold variable will no longer exist. So if I did ;E echo and then the value of kobold in those braces, the number sign and the double quotes, I'm going to get an error because no such variable exists anymore. Global variables, on the other hand, begin with a $, and these are going to stick around after your script exits, and they will not reset until you log off that character. So if I have code that looks like $ kobold equals 6, and then I have stuff happens and script ends, after that script runs, the $ kobold variable is still going to exist and have the value of 6. So if I did ;E echo and then the value of kobold, I'm going to get 6. You might ask, why is this even useful? Well, this is a way for two scripts to talk to each other on the same character. Let's say I have ;Hunt Pro and ;Intel Hunt Pro. Intel Hunt Pro is watching for you see signs of obvious hiding from the game while Hunt Pro hunts. If Intel sees that line, it will set a variable like $someone _ is hiding equals 1. In my combat logic, I have a check that says if $someone is hiding is equal to 1, that means skip that room and move on. Neat, right? Global variables can be rather troublesome though in some scenarios if you don't nail them out correctly. Past me did not code the Hunt Pro follow, patrol, and grounded features to play well with each other. And there's still an outstanding bug where if you do one and then the other, it thinks you're trying to do the first one you chose. So if you're running grounded mode while bugged, it tries to hunt normally without staying in the same room. The issue fixes itself when someone logs out and back on. It's a wee bit frustrating because I need to go through the Hunt Pro code and find all the common global variables used between those two features, and then either nail them out in the right spots or rewrite parts of different sections to fix it. These are the kind of mistakes I don't want to repeat in the polar bear project. If you're wondering about nilling a variable, you can just set it to a default value or nil. Kobold equals nil would set the local variable to nil. Kobold equals 0 sets the local variable to 0. You can do the same thing with the global versions with the $. Setting a variable to 0 gives it the value of a number, integer 0. Setting a variable to nil gives it the value of nothing. You can check if a local or global variable has a nil value with the following. The variable you're checking has to be defined, otherwise you're going to get an error. If kobold.nil echo kobold has no value end, or if $kobold.nil echo kobold has no value end. You learned about strings. We mentioned arrays briefly, and we'll talk about hashes next episode. With these three things, you can actually check if they don't have a value by using .empty ? You can have local arrays and global arrays just like variables by adding the $sign before the array name. So here's a local version. my_array equals open bracket, close bracket. If my_array .empty ? That means that if the array holds no value inside those brackets, I'm going to respond, I didn't find any data inside that array. Let's skip forward to constant variables. Constants are values in Ruby that are meant to stay the same once you set them. They are written in all uppercase letters to make it clear that they should not change. So here we have an example, pi in uppercase equals 3.14. This is a constant. Payday equals Friday, since payday will only ever be on Friday. Rent due equals 1. The rent is always due on the 1st. Even though you can technically change a constant after you initially set it, Ruby is going to warn you if you do, because constants are intended to represent fixed values that don't change during the execution of your program. Using constants helps keep your code clean and makes it clear which values are important and should remain constant. Alright, we're moving on to class and instance variables. These ideas are a bit more advanced, so let's first understand objects and classes in programming. Here's a simple way to picture it. Think of a class as like a blueprint or a design, like a car blueprint. And think of an object as the actual car that you make from that blueprint, like a red sedan or a blue convertible. In programming, an object is a specific thing created from a class. It has attributes, details like your color and a model, and methods, actions that we can do, like drive and honk. For example, if we have a class called car, each car you create, like red car, green car, blue car, is an object. Each car can have different details and perform actions based on the blueprint details, or the class. So objects are the individual items created from a class with their own specific details and abilities. So now that we have an introduction on objects and classes, let's look back at class and instance variables. These are ways to store information in our objects. Instance variables are like personal details for each object. For example, that car object has its own color and model. So these are going to be stored as instance variables, and they start with the @ sign. So here's an example, class car, def initialize, open parentheses, color comma model, close parentheses. Then we're going to define the @color equals the color, and @model equals model. That's going to hold the value for the car's color and the car's model. Then we're going to go on to define a display info. And then we're going to output the color, and we're going to pull the value of those variables. And then we end, and then we're going to create new objects. We're going to have car1 equals car.new, open parenthesis, and then we're going to put in double quotes red, comma, and then double quotes sedan, and then close parentheses. Do the same thing for car2 with car new and use blue convertible. So now when we use the command car1.display_info, it's going to look at all the code we defined, put it all together, and then output the color of red and model sedan. And if we do that for car2, it's going to output blue convertible. Here the @color and @model are instance variables, and each car object will have its own color and model. So class variables. These are shared across all objects of a class. Imagine a total count of all cars we created, which is the same for every car object. Class variables are going to start with the double @ sign. Here's an example like the previous, but we're going to add in the class variable. Class car @total_cars equals 0. That's the class variable for the total number of cars. Then we're going to define the initialize for the color of the model. We're going to put the @cars in there, and we're going to do plus equals 1. And what that does is it increases the total amount of cars each time a new car is created. So each time that initialize fires, it's going to say 1, 2, 3, 4, and it's going to count them. And then we're going to have def self.show_total_cars, and then we're going to puts, and the double quotes, total cars, and then the colon, and then we're going to put our variable in there, the number sign, open brace, at, total underscore cars, close brace, and then close the double quotes. So now we have car1 equals car.new, red sedan, car2 equals car.new, blue convertible, and then car.show underscore total underscore cars is going to output the total amount of cars, and it kept track of those two as we define them. Here at total underscore cars is a class variable, and it keeps track of the total number of cars across all instances. So to summarize things out, instance variables like @color, @model, those are personal details for each object, and class variables are at total underscore cars. That's going to be shared information across all objects of the class. Instance variables are used for details specific to the object, while class variables will be used for information shared by all objects of that class. All right, I know that was a lot. We'll let that digest just a little bit. If you need to come back a little later and watch some of that again, please do. Let's take a step towards a different kind of topic, proc calls. Procs are a handy way to store and reuse blocks of code. Think of a proc as like a recipe that you can use multiple times. So to create a proc, we have to define it with a lowercase variable name. We assign it with proc and put the code inside curly braces. Here's an example, dinosaur equals proc, open brace, we have puts, I am a dinosaur, puts, rar, puts, stomps around. And now if we want to run that proc, we're just going to use .call. In this case, we do dinosaur.call. Procs are great for keeping your code dry by letting you define a block of code once and then use it as many times as you need wherever you need it. Let's get method for a minute. A method is a set of instructions you use to perform a specific task. Once you write it, you can use it many times without rewriting those instructions. And yes, it seems like a proc call, but it's a little different. So to use a method, we first have to define it. You write it once with a name, and then you're going to call it. So here we have def, greet, open parenthesis, name, close parenthesis. We're going to do puts, and then the commands inside the double quotes, hello, comma, and then the value of name, and then we're going to put end, and then we do greet, open parenthesis, open double quote, Alice, close double quote, close parenthesis, and that will output hello Alice when we run the code. We do the same thing for Bob, and it outputs hello Bob. In this example, def greet name defines the method, and greet Alice calls the method using Alice as the name. When you call greet Alice, it will always print hello Alice because it uses the name you provided in that method. Another form of a method is when you're not giving it a value, and you just call the method by name to execute that block of code, very similar to those proc calls. Def sing, fput, sing, I want more mustard please, within double quotes, and then you end, and then type sing. And you're going to sing, I want more mustard please in game. Using code with local variables inside methods can be tricky depending on your scope. So here we have def pizza time, pepperoni equals yum in double quotes because it's a string, and then respond the value of pepperoni, end. And then when we run pizza time, this is going to output yum because that's the value of pepperoni that we defined inside the method pizza time. However, if I tried to then do respond the value of pepperoni outside that code block, I'm going to get an error because pepperoni doesn't exist outside that method. Local variables are only accessible within the local method they're defined in. You can work around this with global variables like I did in Hunt Pro, but it's not always the best practice. Understanding these scopes and how they affect your code will become more clear with practice. When writing code, you might choose between defining methods directly or organizing them into modules, and here's how to decide. For simple scripts, directly defining methods is fine. Def queso, def lechuga, and you put the code for cheese and lettuce in there, and then you call those methods directly with queso and lechuga. For a more complex program, you might consider organizing methods into modules to keep things tidy. Here's an example module. Module taco bar with a capital T, and then you have all your methods, def queso, lechuga, tomate, cebolla. These are different ways to use methods inside modules, and you can use them as part of an instance or class too, which we'll show you in a few minutes. Or you can just include the module directly. And if you want to include the module directly, you'll just type include taco bar, whatever the name of the module was. With the include command, that module's methods are going to be available directly in the current scope. I can now type queso, lechuga, tomate, cebolla, and it knows where to find code for those methods since it's included in our current scope. Using one module with all unique method names, then including the module, can work for you. An example of this is HuntPro. I have one module called HuntPro_toolkit. But what if we have a different scenario where you're using multiple modules and some of those modules have the same method name? Here's an example. Module gold, def award. We're going to give that gold award. Then we have module silver, same thing with an award, but give the silver award. And then module bronze, we're going to define the award and give the bronze award. If you choose to include all of those modules, include gold, silver, and bronze. When I type award, gold.award, silver.award, or bronze.award, they are all going to output the bronze value because include bronze was the last module you included, which has a method called award that overwrote every code that came before it. So those previous methods called award no longer exist. Now within our current scope, due to that include command, anything referencing award is the last value you set it to. In this case, the module with the bronze code. I will add that when you include a module, those methods are then defined in your current play session too. This can directly affect how your code responds to debugging. This means if I took out the lines that said include gold, silver, bronze, and then I ran that script again, I'm still going to get bronze for all 4 outputs. But if I logged off my character and then logged back in and ran the script again, when the computer gets to the line award, it's going to error out because that is not defined in our character's current play session scope. You could consider using include module name right before the method calling the block of code that you want, but that seems like extra work when you could accomplish it in more efficient ways. You would just do include module name and then call your method. Most notably, just use unique names for everything that would not be used by other scripts, but not so complicated that they're impossible to discern what they do. So of these 3 examples, def join, def polarbear_join, and def y1a6090 yada yada yada. Of these 3, I'd much rather go the middle path. This option is less generic, yet not so unique that I'm prone to errors and frustration trying to type it in. Unique variable names and method names should really always be considered, but especially if you're choosing to include multiple modules and the methods within. When I worked on a block of code in PolarBear, I initially had a method called join. There's another script that some of you may use called E05 that also uses code that references a join. This means that when my code first ran, it defined join, and then when E05 tried to run, it was trying to access my join method even when PolarBear was not running, versus the method it needed to be using from E05. The short-term fix was just to log out and log back in, but the long-term fix was to use a more unique name in my structure and use the experience to adopt better coding practices going forward. I mentioned we'd talk about using modules as part of an instance or class instead of including the module outright. Instance methods will be available to instances of the class or module where it's defined. So with the class, it looks like this. Class my class, def greet, puts hello from my class, and then object equals myClass.new, and then object.greet. That's going to put hello from my class. You can use a module within a class to add its methods. This is good for organizing code into reusable pieces. So we have module, greeting module, def greet, puts hello from greeting module, end, and then we have our class, my class, include greeting module, end, then object equals myClass.new, and then object.greet. That's going to put hello from my greeting module. In this example, greeting module defines a method called greet, and my class includes the greeting module, so now my class objects can use the greet method from that module. By including a module, you can extend the functionality of your class with methods defined elsewhere, making your code more organized and reusable. You can define methods that belong to a class or module itself, rather than to instances of the class or module, and these are going to be called class methods or module methods. So class methods are called on the class itself, not on the instances. They're defined with self. So here we have class, my class, def, self.announce, and then we have puts class method announce, end, my class.announce, and then that's going to output the class method announce. With module methods, similarly, they're defined with self and are called on the module itself. So here we have module, my module, def self.announce, puts module method announce, end, and then my module.announce. That would output module method announce. By using that self dot for defining methods in a class or module, You are going to ensure that that method is associated with the class or module rather than with individual instances. This approach helps avoid name conflicts by clearly specifying which class or module the method belongs to. I know this episode has been packed, and there's only 2 more subjects to go. One is Vars, and this is different from variables. Vars is a way for Lich to store settings in your directory that can persist essentially forever until you change them. The Vars values can be loaded up when you run a script. Vars values are unique to that character that you're currently running. So for a graphical example, just type ;Vars setup from within the Lich program. The window may become super huge, and you have to shrink it slightly depending on your display setup. Inside this window, you see Vars values like day_pass_sack, lootsack, mapdb_fwi, trinket, etc. and so forth. If you update a value here, then save it, it's going to be called upon from any script to use that variable name. Closing this window will ask if you want to save the changes you made. So now we have in a script, my script, we're going to echo the value of vars.mapdb_fwi trinket, and that's going to echo whatever value is stored in that variable. I try to avoid using a ton of these for data storage because I don't want to fill up someone's Vars setup window with 1,000 different names and values that can be handled in a much easier way. By visiting the Lich scripting reference page and checking out our last topic, script settings. Settings are going to be specific to a particular script. So if I have a setting in my Hunt Pro script called flee, when I update that setting, it will only be updated and usable from within Hunt Pro. I attempt to make that setting specific to my character in Hunt Pro by adding char.name in brackets between the word settings and the actual setting name. This doesn't seem like it matters anymore, but we'll get back to that in a minute. To load settings, you'll need settings.load, save settings with settings.save, and clear your settings with settings.clear. I don't use that last one because 1, I'd rather just set the value to something else, and 2, I don't want to mess with any other settings for any other scripts. Settings.clear seems like it would clear everything for all scripts, and I'm not looking to inadvertently use a wrecking ball on other working projects. Let's load, define, create, call upon, change, and save some settings. So the first thing you're going to type, we're going to do my script, settings.load. This is going to load the directory settings up for use within your script. Then we're going to add the command settings char name, then the double pipe symbol equals #new. Now here again, you'll see I use char.name, but this may not be needed. So here I'm going to define out some settings, and after the double pipe symbol appears, I'll list out the default value of a setting if it doesn't exist. This value is applied the very first time the setting is created, and once that setting exists, the value on the right of the pipe has no effect. In our example, we'll use apple in double quotes to represent a default string value, and the integer 40 to represent a number. Remember, numbers are not enclosed in quotes. A float number would work too. The difference is an integer is the rounded whole number, positive or negative, like 1, 24, -207, 0. A float number, positive or negative, has decimals, -1.23456 or 8005.0000000001. So here we have my script, settings load, settings char.name. We have our unique string setting equals settings char.name, and then our unique string setting, and then the pipe symbol, and then the default value. Do the same thing for the integer setting, put in the number 40. So now I've loaded up some settings, I've made new ones, I put the value of apple in the string setting, 40 into the integer setting, and those values will remain there as part of your Lich directory for this script. So now I can call the setting to get the value, much like you would call a variable. I let everything load up, and then I start my script, and then I echo those values. So what if you want to change those settings? Well, you would assign them a new value, and then use settings.save to save it into the directory. So here in my code, after the echo, I do settings, and then the unique setting equals the new value, same thing for my number, and then settings.save. If you want to load up those new settings immediately, you need to follow it up with settings.load and define out your variables by loading the new values from the saved settings into them. So here we have the echo, the setting changed, the setting load, and then the output of the new value. And now these settings can be used with the if-else-if type of logic we learned in previous episodes, as well as all of the new concepts that we learned in this one to manage different types of scenarios. Here's the note I mentioned earlier about using char.name within the settings feature. Much like Vars, these script settings seem to be specific to the character you're running anyway, and through testing I discovered that char.name part of the settings command seems a bit redundant. So I'm going to try to take that out on my code going forward. Did we make it? We made it! All right, for application time, create a simple routine where every time you start your test script, a setting gets updated to an alternating value. Pause the video if you want. I'll show you a possible answer in 5 seconds. Here's one possible answer. You have your my script comment, settings.load, settings pipe equals hash.new. You define your setting equals settings, and then pull the value or set the default. And then we have the start of the script. If your setting is equal to the value, respond something, and then take the settings and set it to something new, and then settings.save. Or else, if it has a different value, we'll say something else, and then we define the setting back to our original value, and then close out with settings.save. And now every time you run the script, it's going to alternate back and forth between applesauce and whoa. Next time on the Ruby Dungeon, we talk hashes, learning how to use them for more complex data storage. The _respond command. We're going to discover how to become more bold and enhance our text. We're going to check out the Lich scripting reference message commands that's going to make your text outputs more colorful and engaging. And then we're going to talk the initial stages of designing Polar Bear, where I went wrong, an example debugging technique used in the current project, and some pros and cons of using an AI assistant to learn. I'll see you real soon.